Okay, today we are going to do the fourth lesson of grade 3-4. Let me start sharing my screen, then we'll take it from there, okay? All right, you guys can see my screen? Excellent. Okay, so you know how in the previous weeks we talked about patterns and other kinds of concepts, right? In order to solve. Today we're going to talk about something called as making an organized list, right? You all know what a list is, right? List is a set of related things like days of a week is a list, numbers is a list, alphabets is a list, right? Your favorite Pokemon characters is a list, for example, right? So each one of them is a list. When you write them together in a particular order, it becomes a list. So we're going to start on how to use an organized list using a warm-up question. Okay, let's take a minute and try to solve this. And if you know the answer, raise your hand on Zoom, and then I'll call you so that you can solve it back on the screen. Now, I'm going to challenge you. Remember what we talked in the previous lessons, okay? We're going to read the question twice, thrice. Make sure you are understanding exactly what the question is asking. Make sure you are more than confident in what information you need to use to solve, okay? All right, go ahead. In just 10 more seconds, okay? Okay, all right, Kavin, go ahead.
So first I have a question. Do you feature 122?
Why do you think? Oh, what do you mean? For example, do you consider 122? Yes, you can.
Okay, then what I think I did was correct. So first I just listed down 122, and then I just swapped the 2 into 1, and then again I just swapped these two, so 2, 2, 1.
Mm-hmm.
And because there's two twos, I can't do any more than that. So these are all the combinations to make 5. 1 plus 2 plus 2. And then you can also do 4 plus 1 plus 0.
Mm-hmm.
You can also do 5 plus 0 plus 0. And 3 plus 2 plus 0. So if you follow all of those patterns and just swap it like that, so for instance, 410, 410, 401, 140, 104, and now for 500, 500 is the only thing you can do since there's 2 zeros, and if you put 10 in the hundreds place, it'll just be 2-digit. And then 3. Well, let me just then 320. Sorry, 302, 203, and 230. So I think those are all the ways. Just all that top half.
Okay, what's your answer then?
Well, let me just count them. 12.
this 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay.
Did anyone come up with a different answer that they might like to share?
Like, sorry, like, my handwriting is like really messy. I can't count.
You're very close, Kevin. Hi, Harry.
Hello. I see in the chat, does someone come up with a different answer that they'd like to explain?
I think Shaunak is raising his hand. Go ahead, Shaunak.
Yeah.
So I basically did the same thing, but I didn't see in his list 3 1 1, 1 3 1, and 1 1 3. I didn't see that in the list. So basically 12, because that was the old answer, plus 3, because that's all my new answers, equals 15. So I thought 15 would be the answer. I'm not writing a 15, I can't really see. And that's my answer, 15.
Yeah. That is the right answer. So I think it's Kevin, do you see the ones with 3 was the missed one?
Oh wait, sorry. Oh, I actually mentioned those. Sorry, I actually mentioned those. I just didn't write them down. My thumb was covering them.
Yeah.
Damn.
Yeah, that's okay. So I'm going to ask this question to the group and maybe Harry looking at you, right? How can we make sure that this list is as complete as it can be? Is there a way of thinking or a method that we can follow? Does anybody have an answer?
All
Action?
right. I have
What do you think?
I have a pretty easy method that I like to use with these problems. So the first thing that I do is I say kind of what are parameters here. So the digits are equal to 5. So that kind of sounds like you just have to find all the different combinations of 3 numbers that equal 5. So for instance, 1, or I think I'm drawing.
It's not showing up. Do you want us? Oh,
1
now it shows up. Yep.
plus 1 plus 3. 1 plus 2 plus 2. And I don't think there's any other unique ways of adding those up. I could be wrong. Oh, yes. 4 plus 1 plus 0. Or sorry. And then 2 plus 0 plus 3. I believe those are all the different combinations that you can use. And then, sorry. So I've used, 5, 4, 3, 2, 1. So these are all the different combinations, right? And then you could just rearrange these ones and these 3s and these 5. So like this first one right here, this can make 113, 131, and 311. And this one, 122, 212, 221. And then you could just do this for all 5. So if you notice, all these ones have 3 different solutions. And if you add 3 plus 3 plus 3 plus 3 plus 3, you would end up with 15.
Yeah.
So it's maybe a little bit of a more organized way of doing that. I didn't miss the way that y'all solved it, so that may have been the way that you did it.
Yeah, that's exactly the right way to think about, because this is organized list, right? So when we say organized, you guys see what Harry did when he had the number 113. He did not go and go into other digits like 2s and 4s and 5s, right? He said, what other 3-digit number can I make with the numbers 1, 1, and 3, right? Just reorganizing it. So that's a little bit of organization that if you follow, it's a little bit of discipline to how you make your list, right? Then there is a lot less chance of missing a combination. Okay. Lakshan, did you have anything else to add? I know you raised your hand earlier.
I think I did. So so first I did all the combinations that add to 5
which is more than 100 and less than 200. Then I did it with 200, that is more than 200 and less than 300, and I kept on going.
Very cool.
That can be an effective way of solving the problem. But if you noticed, maybe when you were going through it, that because you weren't just doing something simple like just figuring out different numbers that add up to 5, you're actually trying to go through each one of them. It took you maybe a little bit longer than it might have if you just figured out all the different combinations that add up to 5. Because you had to go it for several hundreds, I don't mean, maybe you're a genius. I could be wrong, but it would take me a little bit to do that. But just figuring out kind of what numbers add up to 5 would be a lot faster.
Okay.
Okay.
Awesome. I hope everyone is warmed up now. All right. So let's take a little pause I hope you all know what these words means, right? Like, because we're going to use this in today's topic, organized list. We just briefly talked about it, right? We said it's presenting those values or data as you call it in an organized pattern way and with enough relationships among them, right? So we today's concept is all about how do you form an organized list to solve a sample problem. Okay, today's entire set of problems are going to be around that. We already talked about patterns, repeating numbers, color, shapes. I think you know what. Harry, do you want to talk about relationships and patterns there?
Sure. You're talking about the first point with the organized list.
Yeah.
So
Anything to call out?
An organized list is basically some kind of list where you have rows and you have columns. So maybe you say the columns are kind of, for example, the last problem, what number combinations we were using. And then the rows were just all the different combinations that made. So let's say you had maybe 3 different sizes of t-shirts and you had 3 different colors. Well, then your organized list would look something like this, where you had maybe a blue, green, and I can't draw over there. Oops. And yellow. And then maybe on this side you had small t-shirts, medium, large. It's if you ever heard of table before, I've gone a little bit off screen here, but basically you say, hey, there's yellow t-shirts, there's maybe 2 combinations, so you would put a 2 here, 3 here, 5 here, whatever it happens to be. But that's what an organized list is going to look like, where in some way in your mind you have it. So it's a list of numbers that make sense in the order that you put them.
Awesome. All right, let's keep going. Okay. I think this slide just talks about, making an organized list. I think we talked at detail about this. Read through this, later on when I send you the deck, okay? All right, let's jump into solving. Hi, Saesha. Do you want to take this one? And we are going to challenge ourselves. We will call somebody from the screen here, and you can just go solve it on the screen as it is happening. Okay. How about we call Kinnera? Kinnera, do you want to try this? Go ahead, try solving it on the screen. Read it. Speak loudly on what do you think is being asked, and if you're stuck somewhere, we are all here to help you. Okay. Let's try solving it. And everyone else, solve it on your piece of paper simultaneously, okay?
And
Go ahead,
Kinnera,
Kinnera.
you're muted, so unmute before talking.
We can't hear you. Can you say hi?
Okay.
Okay, it's hard to hear, Kinnera. Speak up a little bit, please.
So what is the least number of matches we added to the picture in order to get exactly 11 squares?
So Kinnera, tell me, Do you know what the goal of this problem is just by reading it?
So like we have to add matches to get exactly 11 squares.
All right. So could you give the example of what a match is, just so everyone else here maybe they don't understand?
The matches are like
So these little things right here,
yeah.
they're representing a match. These little lines. Yeah.
It's like a matchstick, right? Do you know a matchbox and you want to make fire? You strike a match and you get fire, right? So match is a short form for a matchstick. That's what Harry's circling on the screen for you.
Yeah. So each one of
Yeah.
those little lines is a match. So we're gonna be adding in some form or fashion some matches to this picture to make some more squares.
So right now it has like 2 squares, 3 squares. So we have to like add some matches to the picture to get 11 squares.
Why don't you look a little closer at the picture? I think you'll find more than three squares.
Maybe highlight the 3 squares that you currently see.
Yeah.
And then maybe
Take a pen and draw the 3 squares that you see.
And then I found
okay, so maybe you want to like tally it on the side. I'll do that for you.
I got a pen.
Okay, sure.
If it will connect at least. There we go.
You got 5 so far, right? So Harry counted 5 that you drew. Do you see any more?
so one is over here,
Maybe like yeah.
then here, and then here. And then
Here, I'll draw them out for you. Didn't.
I found these 3.
Put little X's in the 1 by 1s.
Mm-hmm.
And then this.
What about that?
It's like, oh wait. Like another square like this.
All right. If there's one on that side, do you think there's going to be one on the other side as well?
Yeah, like over here.
Right, so that's 8 squares.
And how many more squares do you need?
We need 3 more squares.
All right. So I think you may have found all of the squares. So maybe it's time to start trying to put some matches down. Do you have any idea where you might want to do that?
Do you want to like erase that first, whoever annotated on it, so we can?
There
Yeah.
you go.
Um,
Oh,
Here was in the middle of it.
Do you want to draw where you want to put a match? Perhaps.
Maybe like here.
Mm-hmm.
All right. Would that create another square?
Yeah, like this square and this square.
All right. So we're adding 2 more squares. It looks like we need to get 1 more square. So maybe where could you put another one?
But we need to have it on both sides.
Why do we necessarily need to have a match on both sides?
You could put it anywhere.
Oh,
It just got to be kind of on the grid.
Yeah.
Well, I mean, you could put one there, but wouldn't that make 2 more squares?
Remember that we want exactly 11 squares.
So now we're at 12. If you put one here.
but it's all the line is already drew.
Well, maybe like try looking for other places maybe that you could make more squares.
This is already a square.
Right. So I think maybe what you're looking for here, I'll just give you a little boost on this one. So you putting a match right here, and you wanted to put a match here, correct? But the problem was that it was making 2 squares. Well, that gives you the benefit of being able to actually remove this match right here, because we don't need that anymore. If we have 12 squares and we could just make 11 squares by removing a match, that's probably better, right? Rather than use more matches.
I think that the trick is it's saying least number of matches to get 11, right?
Yeah.
Mm-hmm.
Just one
I think
second. I'll be right back.
Kinera came 90% there. Shaunak, do you want to take it? Do you want to try?
Well, here's how I saw it. So I saw if there was 8 squares, right? So if I did one here, that would make 1 square. And then if I made one here, that would make 2 more squares. That would make one huge one here and one small one here. And if I saw it correctly, that should make 3 squares.
Right.
Mm-hmm.
I think 2 is the answer, isn't it?
Yeah.
Right. I mean, like also to test it out, you could try some other possible areas, like maybe one right here and then here, and then you see 2 is also going to make 3 squares. So it's always best to like check and make sure that you're not like just trying out one possibility.
Is a good thing I've always found. You could see there's several ways to make 3 squares with 2 matches, but it might have been possible maybe on another graph to make 3 squares with 1 match. So a good way to say, hey, you can't make 3 squares with 1 match is just kind of put it everywhere. And I went through that, and you can't put it anywhere.
Yeah, like start from the least possible and then move your way up.
But I think we're a little bit lucky. I'm pretty sure Math Kangaroo is a multiple choice, and I don't think they would have put 1 as one of the solutions. So
yeah.
Yep.
You had a question?
And what does this have to do with making an organized list?
Well, if you think about it, we did have to make an organized list when we were talking about how many squares there were, because we were counting all the squares and we were writing the list on the side.
Because if you hadn't done that, you would have gotten quite confused when you tried to solve it.
Now, I when I was giving an example of an organized list, I used a table, which kind of has 2 different things going on. Now, this only has one thing, which is the amount of squares, but you still have, your squares. If you wanted to put 3 different things, you could put like the size of the square, but you just we have 1 square, you have 2 squares, you have 3 squares. No. Go down the list or just make some tally marks. The point
Yeah.
is, you make some kind of counter or diagram where you can see that the information is put neatly. There's not one particular format that is better than any other one.
Actually, when Kinnara was initially drawing the squares, right?
Yeah.
You saw how she struggled a little bit to make sure that she's not double counting or undercounting, right? Existing squares.
Yeah.
So then Harry stepped in and he said, "Oh, there is a big square, then there is a little square, right? Then there
Yeah.
is a medium size square." So that in itself of counting, I have 3 big squares, 2 medium squares, 3 small squares, is an organized list that will make you 100% sure of how many squares are currently there. And without knowing that, you cannot answer how many more do I need to get to 11, right? So that's where the organization of putting it into a list format helps. To be sure. Yeah. Inara, you got it now? You were almost there. One match short. Okay. All right. Let's keep going. Okay. We're going to call somebody that we haven't called so far. And the lucky winner is Ethan. Ethan, go ahead, read the question loudly and solve it on the screen. And everyone else solve it offline.
Gregory forms 2 numbers with the digits 1, 2, 3, 4, 5, and 6. Both numbers have 3 digits, and each digit is only used once. He adds these 2 numbers. What is the greatest sum Gregory can get?
So maybe you want to start by like identifying the circumstances that you have to work with.
So we get to use the digits 1 through 6.
Mm-hmm.
And each number will be 3 digits.
Right.
Because as a 2 in the hundreds place would have more value than like a 2 in the tens place, we should put our 2 greatest numbers in the hundreds places.
Mm-hmm. So
Next greatest in the tens place, then the least greatest in the ones places. So the greatest number Gregory can get is 1,195.
Did anyone come up with a different answer than that they would like to share?
No, sorry, just 1 second before we move, Harry. Ethan, how did you do your addition again?
maybe you want to figure it out. Something. Okay. Yeah.
Do 642 plus 531, please, Ethan.
Okay.
Yeah, let me
Yeah.
let me help. It's a little confusing because this plus this one and this one go together. This one and this one go together. Those go together.
Yeah.
I think what you did is you added 6 and 5 to get 11.
Yeah. And
then you added 6 and 5 again. Sorry, 4 and 5 to get 9. And you didn't add 4 and 3 to get 7. So I think this is where we might have made a mistake there.
Yeah.
That's why if you're writing this on paper, it's always best to do like this. When you get really confident, even you can still make mistakes.
Like the standard way of writing it up.
Yeah, it's a little bit easier just to visually to see that. Can help with some silly mistakes. Like I'm in calculus and most problems I get wrong because I just did simple math wrong like this. Still,
Yeah. 6 plus 5, right? I mean, starting from hundreds place, start from units place.
I can't
Then,
tell you how many
yeah.
mistakes I've made because I forgot to line them up.
yeah.
Yeah. So is Ethan's answer right? 1173?
Did anyone get a different answer before we talk about this one?
Sure.
I'm trying to look. Nobody got a different answer. Can I get some no's or some
Rona?
yeses?
Shauna, did you get something different?
Before I made a mistake, and once I looked at my paper, I recognized the mistake. I was going to do the same thing where I put it in front, but instead I would already put it in the back, doing the opposite of what I meant to do. I would have
But you agree that Ethan's method would have given you the answer.
Yeah, I think this would give you the opposite answer. I just made a silly mistake and did what I didn't mean to do.
All right. Well, I think Ethan's answer is correct. I don't have like an answer key.
Yeah, it's definitely his. I mean,
so good job, Ethan.
Okay.
And it's just perfect way about going it. Think about the digits, go biggest number.
Okay, so
Saesha, who do you want to call next?
how about Coven?
Okay.
Okay. So yeah, read it out for us.
Yeah, so we know that at least number 1 cannot be lion. So we have 3 other animals to choose from to be number 1. So we can kind of just mix and match, make up our own thing. So let's do G and then E first. Then after that, we can just switch it, E and G. And after that, we can just do E and T. After that, and E.
Mm-hmm.
Then after that, we can do E and L. And that's all we can do for E. Then after that, there's a bit more. So after that, let's go to G. So we can't do GE anymore because they already did it. So we can do G and let's say L. Then LG. Then after line, sorry, not LG because line can't go first. So GL, and then after that, we can do GT and then TG. Then after that, we already did elephant, we did giraffe, we can't do lion, so turtle. So turtle, we already did turtle and giraffe, turtle and elephant, but not turtle and lion. So I think all these are the ways. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ways.
Did anyone get a different answer before we go to this problem? Just gonna look for no's or yeses.
Maybe.
Or no response, either one. Both are good. All right. So
Oh,
I
go ahead.
I believe today's theme was organized lists, if I remember that correctly. So I really love the way you went about this, where you went down each one. I'm actually going to show you a cool trick that you can do with organized lists. If you could actually clear the screen real quick.
Okay, yeah. Wait, yeah.
So you notice how you kept having to go back and check whether you already did something or not?
Yeah.
So there's a way you can actually get around this. So I'm going to make a little list. So let's say we want to start with giraffe. So every one on this list, we're going to start with giraffe. So the first one, we're going to do giraffe elephant. We're going to do giraffe lion, and we're going to do giraffe turtle. All right. Now, the next one on the list, we're going to say hey, we're going to start with elephant. So this one, you're going to start elephant, giraffe, elephant, lion, elephant, turtle. And then we can't start with lion, so there's no row for that. And then for turtle, got to reconnect my pen real quick. We just do turtle. We start with giraffe, then elephant, lion. So you notice how I didn't have to go back and check, like, had I already done that one? It's because you're only going to start with each one when it combines with another. So for instance, you only start with giraffe when elephant, lion, or turtle is second. But you're never going to restart with giraffe if you're checking other animals. So if you go back and you say, hey, I get giraffe, elephant, but I also did elephant, giraffe, then later you'll have to go back and check whether you already did that one. But this way, you don't have to go back and check. So the way I like to do it is I'd like to make rows. I started with that one and then go through the list. And that's a really easy way to do this faster.
And basically it keeps you organized and doesn't get you confused.
Absolutely. And
Yeah.
I know this is 3rd and 4th grade, so I'm not really sure what level y'all are at. Do y'all know how to do multiplication, or is that not in your skill set?
Yes, we
Oh,
know.
perfect. You know how to do multiplication. So whenever you see a problem like this, there's a very fast way of doing it. Now, for this one specifically, it's going to be slightly different because it says you can't count lions. But typically, for the purposes of explaining, let's assume that you can count lions. By the way, it would just be another row of 3 if you could count lions. If you notice, this looks a whole lot like a square, or basically you're multiplying. So what I like to do is you count the number in a different list, in this case 4. So you have giraffe, elephant, lion, and turtle. And in order to find the number of unique combinations, you take 4 and you multiply it by 1 less than that. So this would be 4 times 3. Now, because you don't start with lion ever, you actually have to take 1 from the 4. But let's say we did start with lion, you'd have, sorry, my iPad is dying and I can't write. Lion, giraffe, lion, elephant, lion, turtle. So you'd have 12 right here. So if you notice, 4 times 3 is actually 12. So if you have a much larger problem that you have to get all the combinations for, this can be really, really, really useful.
Instead of like listing all of them out.
Instead of having to list them all out. So for instance, if we go back to the warm-up problem, if you could scroll all the way back up there, that's a little bit far. You got me? We could scroll back to the warm-up problem so we can check it again. This new method.
Sure. You want to?
Also, I'm trying to delete my stuff. It's
Yeah.
not very active. I don't know if you can clear my stuff. My iPad has died.
I definitely can. Hang on. Here's my annotation.
All right. Well, if we go back to this, right, we have a certain amount of combinations, right? We determined there were 5 different combinations, right? And there's 3 digits in the number. So we can just take 5 combinations, whichever, if I remember, they were like 113, 122, 104, but there were 5 different combinations, right? And hey, there's 3 digits. So you just want to multiply that by 3. And that would have gotten you your answer 15 immediately, if you know, practice multiplication. So that's a really good way of using that in these types of problems. And I'm pretty sure, I haven't looked ahead at this, but I'm pretty sure there will be more problems like this where we can absolutely use that to just solve the problem. So keep that in mind.
Is there a big kid or upgrade word for that, where you did 5 times 3, that concept?
So there's 2 different concepts actually. This one, there's 5 different combinations of numbers that add up to 5. You can count those out individually. I believe there's a formula for that we don't need to know for the purposes of this. But if you say, hey, there's 3, instead of counting them all up, you see there's 5 groups of 3. You can just multiply them instead of actually adding them individually. if we go down to the other one,
Mhm.
the keyword that you're looking for there is two different, right there, two different animals. So for instance, if she wanted to see three different animals, and there's more, there's different stuff you can do, but the keyword here is two different animals. So that means that you're going to multiply two numbers, the initial number right here, which is 4, and the second number, which is 3. Now, if there were more numbers, which I don't think you'll ever see, you could do some other stuff. But the key one here, two different.
But are we actually going? No. Is Nana coming?
Uh, I think we can move on. I'm sorry.
Okay. No, but this is a really cool way to verify, right? Like Harry's point of 4 times 2
So
minus
4 times 1 less than 4, which would be 3.
all right, moving on. So do we want to continue with this, or do we want to switch to the next one and learn a new concept today? What do you guys think? Continue?
I think we can use this problem to practice multiplication, actually.
Go ahead. Who are we calling?
Who wants to go?
Let's say, has Lakshin tried? Lakshin? Go ahead, read the problem loudly and try to solve on the screen. Harry and Saesha will help you.
Olga has 3 cards, as shown in the picture. Using them, she can form different numbers, for example, 989, 986, and so on. How many 3-digit numbers can she form using the cards?
I'm just checking. Can we rotate the cards like the 9 and the 6?
I think because it does not say you cannot, you can assume that you can rotate.
You can actually assume that you can rotate because it says, for example, and then it says
Mhm.
989 and 986.
Right.
So actually, this one's a little, you would have to do a little bit more complex thinking to use multiplication. So maybe it's just better to actually create an organized list, because you can actually flip the cards, which means that you have more numbers than you have. Wait, no, it's actually a great time to use it. I was wrong. So if we're allowed to flip this card and this card, can anyone tell me how many different digits we're actually allowed to use?
Lakshin, what do you think? How many different digits are there for you to use?
I don't really know.
Oh, well, we can make a list of ones that you find. So what's a digit that you're allowed to use, for instance?
8.
All right. What's another digit that you're allowed to use? And how many times can you use 9?
3 times.
How can you use 9 3 times? If I handed you these 3 cards, how would you make 3 9s?
Never mind. You can only do 9 one time.
I think you can do it more than one time, because remember, you can flip the 6 upside down.
Oh, yeah.
Mhm.
2 times.
All right, 2 times. Is there any other numbers you can use?
You can use 6 2 times.
Right.
All right. Oh, yeah,
Sorry.
we're all drawing on top of each other.
Yeah.
The Wild West out here. All right.
Saesha,
So,
let Harry take this one and you take the next one, okay?
oh, I'm sorry. Did I steal someone's problem?
No, it's okay. That's okay. Go ahead.
All right.
So you're helping Lakshin solve the problem.
So, how many numbers is this right here, would you say?
5.
5. All right. So, let's pretend that we don't know what these numbers are, and let's just call them 1, 2, 3, 4, and 5. All right. Because if you think about it, they're all unique. They're all different. And we're only using them one time, right?
Yeah.
But there's a little bit of a caveat here that you can't use, let's say, 2 9s and 1 6. That's not something that you can do. So it's a little bit interesting in that way. So do you have any idea how you might go about making an ordered list with this?
Not really.
Not really. Okay. Does anyone else have any ideas how you might make an ordered list with this? You can feel free to unmute.
Shonak, what about you?
Well, how I solved it was like completely different from how I solved from making an organized list. So first, I knew that you could make 9, 8, and 6. There's 3 possibilities, so that would be 3 times. But then you are allowed, but then you still have an extra card, so you can count that again, which would be 3. And then for some reason my brain stopped working. So I just guessed 2, and then I guessed 18. This part of my brain just suddenly stopped working.
So you don't know what the answer is, but you're going to guess 18. Is that correct?
Yeah. Well, I know what this part is here. Yeah, but then I kind of zoned out over here.
All right. So maybe how I might go about this. So creating an ordered list, and your typical ordered list, you can go through the numbers, and for each case, you say, hey, for 8, we can go. I like to do the list like this, where it's like, hey, I can start every number with 8 9, or actually I think it's most correct to go 9 9, right? And then reasonably speaking, you know that you can't use a 6 after those 9s because the 9s have, or 6s have already been used over here because you flipped the 6s upside down. So the only number you can create with 9 9 is 998. And so you go to the next lowest one. So maybe I want to start with 9 8. And then there's 2 numbers that you can make with this. So 9 8 9, 9 8 6. And then we can keep going down. So the next lowest one would be 9 6. Same deal with 9 9. You're already using both of those cards you can turn upside down. So you can only get 9 6 8. Do you know where to continue from here?
Anybody?
Shonak?
I feel like I feel like we haven't done 6 6 yet. So I would do.
Maybe we can go down by the what number it is. So we actually end with 6 6 because we want to make sure we hit every number we possibly can.
Okay, so
that makes any sense.
So Harry is going in the descending order of the digits that you have.
Yes. So what would maybe be the next largest number below 96 that you could
Well,
make?
that would be 89.
Right?
So how many 3 digits numbers could you make with these restraints that start with 8 9?
You could do 8 9. You could do 8 9, and you still have 1 card left, so you could do 8 9 9, or you can do 8 9, and you can flip the last digit and do 8 9 6.
Right.
So that would be 2 possibilities.
All right, and so it's to save some screen space, I'm gonna go ahead and count the current amount that we have. So we have 1 in the top row, 2 in the second, 2 3 4 5 6. So we have 6 so far. I'm gonna put that, if I can erase properly, I'm gonna put that in this corner. We're gonna keep going down. So we ended on 8 9. So we're gonna move on to 8 8. Oh wait, we can't do 8 8.
Yeah.
Yeah, that's impossible.
It hit me suddenly at that moment, of course.
So then that would be 8 6.
So yeah, 8 6. So
which would then convert into 8 6 9 and 8, 6, 6.
Making our number of possibilities 8 so far.
Yeah. Here, I'll put some tallies. Tallies are very useful for counting stuff. All right, we have 8 so far. And if we go down one more step, we get 6, 9. And so we're using both of our 6 and both of our 6s / 9. So we remember the only possibility could be 6, 9, 8. So we have one more there. And so we actually have 2 more. Can anyone guess how many is going to be in the next one? Kind of noticed a pattern here. For 6, 8. So you can just talk. You don't have to mute.
So
2.
6, 8, 6, and 6, 8, 9. So 2.
2. So if you've noticed, there have been so far. Well, if I list 6, 6 down here, there have been so far 4 different possibilities. 8 different possibilities going from 9, 9 and all the way down to 6, 6. And it keeps alternating between 2 being available and 1 being available. So, even in this point, I've become brainless and just start writing 2 and 1. I don't even have to write out the numbers because I kind of see a pattern is forming. So if this had been a much longer list, maybe, then I would have said, I'm just going to write 2 and 1 and 2 and 1 and 2 and 1 all the way down the list and then added them up. So in this case, we would have had 6 from the first one and 6 from the second one, which would have given us 12, because if you add 6 and 6, you get 12. So does that make sense? How we went down orderly. We made sure we got everyone.
Yeah.
Because silly mistakes are going to get you in the end when it's like down to that one problem, whether you placed or not. It's going to be really helpful for you.
Especially in problems that involve like combinations and stuff like this.
Absolutely.
Yeah, I think they gave a hint here, right? Like to Saisha's question on, can I flip them and make that 9 into a 6? By giving 9, 8, 6, they gave you that hint. That's probably the trickiest part.
So don't be like me and read the question.
You're being too hard on yourself, Saisha.
Yeah.
Anyone has any question on what Harry explained? Everybody got this? I think this is something that you should go, after your dinner, after this class and dinner, try to solve this once more. What's the answer that you're supposed to get?
It would be 12 on this one.
12, right? Yes.
Yeah.
12. All right.
And you could have gotten this answer by assuming that you had 5 unique digits and then subtracting the 3 cases in which you didn't. So like if you were trying to multiply and then just remove the cases that didn't work, you would have had 5. Well, if you were starting from the base with like absolutely no exceptions, you would have had 5 times 4. You would have had 5 times 3, and then you would have noticed that you can't use 8 twice, and you would have subtracted 3 cases. So that would be 15 minus 3. But it's a little bit less useful in this problem to just multiply.
It would kind of confuse you if you don't get it.
Multiplication will become more useful in higher levels of this type of problem, because you'll be seeing this through Math Kangaroo until you reached, the end, like 12th grade. But it will just get like larger and larger and larger numbers. It forces you to think efficiently on how you can best solve the problem, and less about necessarily can you do it, but how well and how fast and how easy the problem is for you. It needs to feel like you've been doing this problem forever and you're not having any issue. But at the same time, you can't get too I don't know the correct word for it, but you can't just come in confidently, say, not read the question and then miss something small, because I know, at least for me, that's where I missed a lot of my problems when I was growing up.
Yeah.
Okay. It's still to this day.
Do we want to do one more? Shaunak?
I think we
I
have
think you're
time for
saying
one more.
yes. Yeah.
I don't know.
Oh, this is a fun one. I have a feeling for this. All right, let's do one before we call it a day. Come on.
Okay. Christy has to sell 10 glass bells, which vary in price. $1, $2, $2, $3. I'm just gonna skip the dollars. 4, 5, 6, 7, 8, 9, and 10. How many ways can Christy divide all the glass bells into 3 packages so that each package has the same price? Oh, I already know that we have to add 1 plus 2 plus 3 and so on, blah blah blah, and then we would get 55. Why am I doing this? Well, the reason is because we have to divide them into 3 packages. So I would then have to divide them into 3 packages, which means that each total should be 13. So each package should be $13. That's minus package itself. So let's just remove this because we need more space. So then we would have to calculate every single possible way we could get 13 in each package. So then how can we make 13? We could do 6 and 7, 6 plus 7. And then we can do 8 plus 3. No, sorry. 8 plus 5. I got that.
Oh, I got you.
And then the remaining ones would be 1 plus 2 plus 3, but we only got if you add all of them up, it should be 13, so we don't have to calculate this last one. So that's one possibility. Now we might be able to. I feel like this strategy might be very slow, but I'm still making a list. Actually, I have no idea. I honestly have no idea how to do this faster.
So it's not maybe less about this one being faster and more about kind of figuring out how to approach this problem. You did something really great, which is figuring out one case which this works. And I'm gonna actually take a second to think about this problem because I thought that you were trying to make as many boxes as possible, which is not what it was. So if they all have to be the same amount, you're absolutely correct that they would all have to be 13, except that it wouldn't necessarily be that way. For instance, if you wanted to add up, let's say, no, let me think about it.
I disagree with Shawnok.
Would you like to share? Because I haven't quite figured this one out yet.
Okay, Shawnok, I agreed with Shawnok how he added how he added 1 to 10 and he got 55, but Shawnok's division was wrong. So it'll be like this. So there has to be 2 packages that has three glasses in it, and then 1 package that has 4 glasses in it.
That's a very, very important point you're making, Lakshan. So the fact that there is a reminder, what could that mean from our ability to break it into 3 packages? Go ahead, Shaunak.
I came up with an idea, and then immediately. So my idea was that we would have to remove one, but then I remember that Christy has to sell all 10 of it.
Mm. Yeah.
So I really have no idea how this works.
Is that a way you're saying this is not possible?
Kind of.
Mm-hmm.
I think a good way to do a possibility check on this one. I think you were very very wise in finding a case in which this did work, where you had one box and draw a box at least. Let's find out if I can. We have one box, and this box has the numbers 1, 2, 3, and 7 in it. And then this box has, if I remember correctly, 5 and 8. And then
Mm-hmm.
this box has 4 and 9. Now, if you think about it, it doesn't matter how many are in there, and you have these beautiful numbers here, 1, 2, and 3. And what I like about those numbers is they can add up into other stuff. Oh wait, we haven't used 6 though, so I don't think there's a working
10.
case.
And 10.
Right.
Oh no, yeah. And 10, right? You have 6 and 10.
Yeah.
Oh, that's true. Well, I don't think there is a working case actually.
Yeah.
The remainder would suggest there's not.
Yeah. You don't have like a third of a dollar priced glass bell.
I want to say something. Yeah, but Christy never said that she has to put an equal number of bells into 3 packages.
Right, but the
It's not the equal number of
price,
bills. Yeah,
the
that's right.
price of the bells is what's important here, right?
Mhm.
And as we just discovered, there's no way to get the price to 18 and 1/3 because there's no 1/3 unit.
Because
Mhm.
none of them are priced at a third of a dollar.
Yeah, so
they
if
all have to be
we
even. Because if you think about it, you have 55. You have $55 right here, and you have 3 boxes that are 18. But you just have the spare dollar lying over here.
But then we have to remember that she has to sell all the bells.
So we have this $1 here. It's gonna get left all by itself. It's gonna be very sad.
I can have the dollar, but I don't think I'm allowed to have it.
Yeah.
If we actually saw this, right? So this is from the 2013 Math Kangaroo, right? And we know that this is always a multiple choice. In a way, that is a good thing for us. I'm betting that there would have been an option that says not possible.
Yeah.
Yeah.
There would have been a 0. It would have probably looked something like 0, 1,
0.
2, and then 5. And then some ridiculously big number that's obviously not it.
Yeah.
Now, I think
Mhm.
While we're here, theoretically, 1 is not in there, and you have some combination of balls that works, and you're trying to find different solutions. What I was going to say is the easiest way is saying, hey, maybe you have 4 in this box and 1 and 3 in this box. Well, because 1 plus 3 equals 4, you can kind of just swap these 2 around. So just keep that in mind if you ever do a problem like this where there is a certain amount of solutions. But I think that's not for this case.
Awesome.
I think that wraps it up for today. What do you think?
Think so. Does anyone have a favorite problem that we solved today? Shaunak?
This one, because since we didn't have 0 the answer, it tricked us all up because there wasn't 0 the answer. Because if it was there, then we would have obviously just chose that. but then we kept on looking for options because we never knew that 0 was an option.
That's right.
Or
Yeah.
like the open-ended questions are a little more challenging because it could be anything.
Hey, but can we thank Lakshan for finding that issue with the division, which made us realize there is a reminder? Thank you,
Yeah.
Lakshan.
Yeah.
Awesome.
And this kind of problem is pretty nice to solve, because if it was a multiple choice, it probably would have dawned on us a lot faster that 0 could be an answer, because I'm thinking to myself, are the glass balls even uniquely priced? For instance, are all of them just $1? Are all of them just $3, $4, $5? Could they be in a mix of any of them? But that seems too big of a scale, So being able to see that, 250 wasn't an option would be helpful in this kind of problem.
Right. And it's not like you could like split up a glass bell and like be like, oh, look, it's equally priced.
I don't want to buy such a glass ball that is broken.
Yeah.
Awesome. Any other closing comments from anybody else? Kavin, Ethan, Kindara? Anything from you all? Okay. All right. So what we'll do is we'll send this lesson. There are a couple more problems in this that we didn't get to. There are some bonus problems. Go ahead and solve them. And then there is a homework that is. Are you all doing the homework that's coming your way after every lesson? Shaunak? Not doing.
Well, I don't really do them until I remind my dad that I have to do them.
You have to remind your dad. Okay, go remind your dad, okay, that you have to do your homework, okay? All right, I'll also remind your dad, okay? That please print that homework for Shaunak, okay? All right. Awesome. Can we thank Harry and Saesha for today's lesson? All about organized lists. Awesome. All right. Thank you all so much. Have a good weekend. We'll see you soon, okay? Thank you, Harry, for stepping in.
No problem.
Bye.
Bye.
Adios.